Hi guys. Today we're going to look at some properties that similar triangles have. So first, make sure that you know the difference between triangles that are similar and triangles that are congruent. So for triangles to be similar, what that means is that all the angles are congruent, but the sides are not. So the sides will have the same ratio though, and that's what we're going to explore today. So for a quick reminder, there's three different theorems or postulates that we have that prove that triangles are similar. The first one is AA for angle-angle. It just means that if any two angles are congruent on a pair of triangles, that they're going to end up being similar. Because if two of the angles are congruent, the third angle has to be congruent since there's 180 degrees in the triangle. The other one is side, side, side. Now, not congruent, but for them all to have the same ratio. So if you have one triangle and another triangle and the ratio is 2:1 on all those sides, then that would make it similar. And then the last one, SAS, means that you have two corresponding sides that have the same ratio and that the angle in between those corresponding sides is going to be congruent to the angle on the other triangle. So let's take a look at some examples real quick. You're going to see real fast why I'm a math teacher and not an artist, so I apologize. It won't be drawn to scale. So we have triangle A, B, C, and then we have triangle D, E, F. So the things that we know about these triangles is we know that B is congruent to E and A is congruent to D. So we know that these are similar by our first theorem here, angle-angle. So if I was to list these triangles correctly, according to them being similar, I would write it like this. Triangle A, B, C is similar to triangle D, E, F. And you want to make sure that you're naming the corresponding parts in the same order. So now if I note, let's see, one set of sides here to be 8 and 12, and then I know that AB is 10, and I want to solve for DE. So I know that the sides have to all have the same ratio. So what that means is that AB over DE is equal to AC over DF. Okay, and this third side would also have the same ratio. But for this problem, this is going to help us get the side that we're interested in. So I plug in what I know. So I know AB is 10. And then I don't know what DE is, so that's going to be our X. And then AC is 8 over DF is 12. So now I just need to solve for that missing side X. So we're going to use cross multiplication. So to cross multiply, these dudes are buddies, and these dudes are buddies. So I multiply 8 times X, which is going to give us 8X, 10 times 12, which will give us 120. Divide both sides by 8. X equals 15. So that would be this missing side up here. All right, so let's check out one more example. So you're going to see some problems that give you something similar to this. Let's Now, this sign here means that these two lines are parallel, which is going to be really important in proving that this triangle here is similar to this triangle here. So you have to kind of remember some of the concepts that you know about parallel lines. So the concept that we're going to use here is when you have two parallel lines cut by a transversal, or a line that goes through both of them, you know that the corresponding angles are going to be congruent. So I know that this is congruent to this, this is congruent to this, and obviously that one has to be congruent because it's the same angle. So that's like our reflexive property there. So I know that these are similar triangles, and then let's see what we know about this guy. So this length here, let's name this L, M, N, Q, P. So I know that Ln is 6, and Q is 2, and I know MP is 3. So this one's going to be a little bit different. So now keep in mind what the similar triangles are. Okay, it's this little guy in here and this big guy. So those are the ratios that are going to be the same. So I know that Ln over LQ, so the little over the big is equal to Lm over LP. So let's write down what we know about these sides. So Ln is 6 over LQ. So for LQ, you have to add these two components together. So I have 8. And then here, this distance here, Ln, is what we're solving for, x. That's our unknown. But, so I have Lm is x. But now this length, so just like we had to add these two numbers to get that whole length of the bigger triangle, we do the same thing here. So we add the x plus 3. And now we cross multiply. So it looks a little bit different, right? Because we have this rational expression over here. But same exact idea. So these dudes get multiplied, and these dudes get multiplied. We'll start with the easy one. So 8 times x is 8x. And now here's a really easy place to make a mistake. So I have 6 times the whole quantity of x plus 3. So not just 6x plus 3. That 3 has to get multiplied by the 6 also. So now I'm going to do distributive property. So I have 8x is equal to 6x plus 18. And now I just need to solve for x. So I'm going to subtract 6x from both sides. I'm going to come back over here. So I have 8x minus 6x is 2x equals, those guys cancel. I bring the 18 over, divide both sides by 2, x equals 9. So if our question asked us what Lm was, that would be 9. If it asked us LP, then we would just add those two numbers together for 12. Thanks for joining. See you next time.